Let's take a look at the main things you need to know for the midterm. You should also be reviewing the homeworks. So the midterm questions will be similar to homework questions. Chapter 1, we looked at whole numbers and the basic operations. Okay, so doing everything by hand. Addition, for example, 469 plus 83. How do you do that by hand? Well, set it up vertically like this. Line up the ones, the tens, any hundreds. And we need the idea of carrying. Okay, so starting in the ones place, 9 plus 3 is 12. Write down the 2 and carry the 1. So that's 110 getting carried into the tens place. And then 1 plus 6 plus 8 is 15. Write down the 5, carry the 1. This time the 1 represents 100. And 1 plus 4 is 5. So the answer, 552. Yeah, it's nice if you put a box around the answer. So yeah, for this test you have to show your work, so show your calculation, and then don't just leave it like that. Then say what the answer is explicitly. For subtraction, that's a similar kind of setup. So put the numbers vertically. 6,107 minus 4,583. So the number you're subtracting goes on the bottom. Okay, now start in the ones. So 7 minus 3 is 4. Now we have 0 minus 8. Okay, we can't subtract 8 from 0, so we need the idea of borrowing. So borrow from the next column. So I'm going to borrow this 1. It's really 100, so that becomes 10 tens. Okay, so this borrowing idea we need for subtraction. Now 10 minus 8 is 2. Same problem again. We can't subtract 5 from 0, so we need to borrow from the next column. So borrow 1,000, that's 10 hundredths. 10 minus 5 is 5. And 4 from 5 is 1. So yeah, maybe it's clearer here. And so just make sure in each step you're subtracting something small from something bigger. Otherwise, you have to borrow. And here's the answer. Okay, and a key thing for this, the way we're doing it, vertical adding and subtracting, is you have to keep everything lined up, and each column lined up neatly, so you don't make any mistakes. Multiplying, that's slightly different. So here, multiplying two whole numbers, we can do it like this, vertically. Line up the ones, tens, and hundreds again. So this is the setup. Then the first step is to multiply by the 6 in the ones place. 6 times 4 is 24. Write down the 4, carry the 2. 6 times 9 is 54. Plus the 2 is 56. Write down the 6, carry the 5. 6 times 3 is 18. Plus the 5 is 23. Next, we multiply by the 8. Now this is 8 tens, so the answer has to start over here in the tens place. Okay, so on the homeworks, lots of you forgot to shift over this second row. So 8 times 4 is 32. Write down the 2 here under the 6 in the tens place, carry the 3. 8 times 9 is 72, plus the 3 is 75. Write down the 5, carry the 7. 8 times 3 is 24, plus the 7 is 31. And again, keep everything neat. So we have neat columns, ones, tens, hundreds. And then the last step is to add those 2 rows to get this answer. So 33,884. All right, so yeah, just make sure to shift that second row. If there was a third row, if there was 3 digits on the bottom, then you would have to move one more place. And the last operation is division. Yes, some people confused about this in the homework. In this example, divide 347 by 9, and we want to find the quotient and the remainder. So how many times does 9 fit into 347, and is there anything left over? Okay, so this is the setup. So the number you're dividing by, the divisor, that goes on the outside, and the number you're dividing goes inside. Okay, so make sure you set it up right with the right number on the outside. 9 into 3, it goes 0 times. 9 into 34. So what's the most times 9 goes into 34? Well, it fits in 2 times. 2 times 9 is 18. But that's not the best you can do. 9 times 3 is 27. 9 times 4 is 36. That's too big. So the best you can do is 3 times. Now the 3, it's important that the 3 goes over the 4. So don't put the 3 here, put it, we're looking at 34, so the 3 has to go over the 4. 3 times 9 is 27, subtract, you get 7. And now bring down this 7. So we have 77, and you can see to find the quotient, there's an open space here, so we have to find what number goes here. 9 goes into 77. The best you can do is 8 times. That's 9 8 72. Subtract. We get a 5. All right, so you can see we've finished the calculation. So above the 347, we have 38. That's the quotient. So 9 fits into 347 38 times. And there's 5 left over. So you could check this answer. So if you multiply 9 times 38 and then add 5, you should be getting 347. So here's the quotient. The remainder is down here, and you can write it out in words or in using our R notation. So the answer is 38 R5. That's quotient 38, remainder 5. That's how division works. So these 4 operations, we have to be able to combine them in the right order. Okay, so this is our convention. So do things in parentheses first. Take care of powers, exponents, roots next. And once you've done all of that, then do any multiplications and divisions from left to right. And additions and subtractions should be done last. Again, working from left to right. Okay, so sometimes you're dividing before you're multiplying if the division's on the left. Sometimes you're subtracting before you're adding if the subtraction's on the left. And some examples of that. So lots of people made a mistake on this one on the homework. So 4 plus 24 is 28, and then 28 divided by 4 is 7. But that's not the correct order. So we should be dividing before we add. So you should do this part first. 24 divided by 4 is 6, and then 4 plus 6 is 10. All right, so you do always divide before you add, unless, so if there were parentheses here, okay, then the answer would be 7. You have to do this addition first, but no parentheses here, so it's division first. Two things to do here. There's a power, exponent 3, and there's a subtraction. So we'll take care of this exponent first. 2 to the power 3. That's 2 times 2 times 2. We get 8, and then 10 minus 8 is 2. This example, so we have parentheses in this one. So we'll do a side calculation to figure out what's in the parentheses. 2 minus the square root of 16. Here we take care of square roots before we do subtraction. So it's the square root of 16, that's 4. And then 2 minus 4 is negative 2. All right, so inside the parentheses, it's really negative 2. And what do we do next? Well, we have an addition. And what is the 3 doing to the negative 2? It's like a multiplication. Okay, so this is really a multiplication, so we have to do that. Take care of that multiplication before the addition. 3 times negative 2 is negative 6, and 9 plus negative 6 is 3. Yeah, we'll look at multiplying and adding sign numbers in more detail. But yeah, if you're multiplying two numbers with different signs, the answer is negative. And if you're adding two numbers with different signs, you're really subtracting the absolute values. And the answer is the same sign as the biggest number. So that's this is the same as 9 minus 6, and the answer is positive. One more order of operations. Yes, some people fell into this trap in the homework. So we have three operations here: multiplication, division, and another multiplication. So it's not true that you do multiplications before division. It's you just go left to right. Okay, so multiplications and divisions, just go from left to right. So it's 10 times 2 first, that's 20. Then 20 divided by 5 is 4 next. And then this last multiplication on the right comes last. 4 times 2 is 8. Yeah, you get a different answer if you did the multiplications first. So 20 divided by 10 is 2, but that's not the correct order. One application we looked at for these combining these operations, we looked at areas and areas and perimeters of different shapes. So the area, that's you're measuring the space inside the shape. The perimeter, you're measuring the length around the outside. So for example, a park is in the shape of a rectangle with length 15 miles and width 8 miles. All right, so that's a big park. Find A, its perimeter, and B, its area. So here's a picture of the park. So for the perimeter, we're adding up this length plus this length plus this length plus this length. So it's really 2 times 15 plus 2 times 8. You can write it like that. So the perimeter of a rectangle is always twice the length plus twice the width. Multiplication before addition, so it's 30 plus 16, that's 46. And yeah, don't forget the units. So the perimeter is a length, so that's 46 miles. All right, so if you walked around the outside of this park, that would be a 46-mile walk. How about the area? So the area of a rectangle, that's easy. It's just the length times the width. So we have a bigger multiplication here. So 15 times 8. So doing it by hand, that's 8 times 5 is 40. Write down the 0, carry the 4. 8 times 1 is 8, plus the 4 is 12. So the area is 120. 120 watts. Well, for area we need square units, so it's square miles. Okay, so here's 1 square mile, 2 square miles. So we're measuring this space inside the park. So it's measured in these square units, square miles. So there's 120 square miles. All right, so yep, on the homework, yep, not too many people getting the units correct. Just remember, for area you need square units. So if this was feet, we need square feet, or square centimeters, square kilometers. All right, so this is a simple application of combining operations. Yeah, let's talk more about those sign numbers. So we looked at sign numbers in chapter 2. It's 2 basic ideas. The absolute value of any number is just its positive part. The opposite of a number means you're switching the sign. So the opposite of 18 is negative 18. The opposite of negative 13 is positive 13. Okay, so this, when you see 2 minus signs like this, 2 negatives, so the opposite of a negative number is, you're back to positive, so it simplifies like this. When you're multiplying and dividing 2 sign numbers, the sign of the answer is easy. If you're multiplying 2 numbers with the same sign, the answer is always positive. Multiplying 2 numbers with different signs, the answer is always negative. So a negative times a negative is positive. A positive times a negative is negative. And then just multiply and divide the absolute values to get the number. And so negative 2 times negative 3. And yes, so when you see parentheses written like this, the operation's multiplication, not addition. We're multiplying here. So same sign, so the answer is positive 6. Here, different signs, we're multiplying, so negative 32. Same for division, different signs here, so the answer is negative, and 6 divided by 3 is 2. Same signs here, so the answer is positive, and 32 divided by 4 is 8. And yeah, you can see these are really equivalent. And so are these. It's really the same information. So if you multiply 8 by negative 4, you get this, and negative 32. And then if you divide this by negative 4, you're back to the beginning. So dividing by negative 4 is the opposite, the inverse of multiplying by negative 4. And the same here, the same for negative 3. So multiplying and dividing 2 sign numbers is easy. It's a bit more difficult to add 2 sign numbers. If you're adding 2 numbers with the same sign, you add the absolute values and keep the sign. But if you're adding 2 numbers with different signs, you have to subtract the absolute values So it's the larger absolute value minus the smaller, and then use the sign of the number with the biggest absolute value. So the biggest number controls the sign of the answer. So negative 12 plus negative 13. These two numbers have the same sign, so you add their absolute values, 25, and keep the sign. So the same sign here is negative, so the answer is negative 25. For this one, we're adding two numbers with different signs. The absolute values are 12 and 16. Okay, so for different signs, we have to subtract the absolute values. So 16 minus 12 is 4. And the biggest number here is positive, so the answer is positive 4. In the other type of case, 18 plus negative 23. So here again, they have different signs. These are the absolute values. We have to subtract the absolute values. We get 5, but this time the bigger number is negative, so the answer is negative 5. All right, so I hope you're getting used to this for adding sign numbers. Yeah, it's kind of complicated, but once you've done a few, so with some practice, it gets easier. All right, so this is the rule just for addition. For subtracting, you just have to remember that subtracting a number is the same as adding its opposite. Okay, so for these, the operation was addition. Now we have a new operation, subtraction. So this is negative 3 minus 6. Okay, so subtracting 6 is the same as adding negative 6. Okay, so the opposite of 6 is negative 6. And now we're back to an addition question. So add the absolute values, keep the sign, negative 9. All right, so if you like, it's keep, change, change. Keep the first number, change the subtraction to addition, and change the second number to its opposite. So that's the deal. Negative 4 minus negative 7, that's equivalent to negative 4 plus the opposite of negative 7, so plus 7. So we've changed the subtraction to addition, changed the negative 7 to its opposite, 7. So we have an equivalent addition question. So now we're back to adding two numbers with different signs. So subtract the absolute values and use the sign of the bigger number, that's the 7. So plus 3. Keep, change, change. So 22 plus the opposite of negative 21, so plus 21. And that's easy, 43. All right, so again, yeah, when you see this situation with two negatives, it just turns into a positive plus 13. How about powers and roots of sign numbers? Here we have negative 3 to the power 3. The base here is -3. And the exponent means just multiply the base by itself 3 times. -3 times -3 is +9. And 9 times -3 is -27. How about this one? So we have a negative sign out front. Inside the parentheses, we have a -2, and the exponent is 4. So yeah, I saw lots of people in the homework kind of canceling these negatives and then just doing things like 2 to the power 4 is 16. That's not correct here. Yeah, this exponent's kind of messing that up. So really what's happening here is we have this -2, that's the base to the power 4. And then this minus sign out front means the opposite of all that. Okay, so the way to read this is really we have to take care of this -2 to the power 4 first. And then it's the opposite of that. Okay, yeah, so the base is -2, so it's -2 times -2 times -2 times -2. And you could do these in pairs. So that's 4 times 4, 16. And then we need the opposite of that, so -16. So for these exponents, yeah, it's important to pay attention to what the base is, what number is getting multiplied by itself. Here it's -2 multiplied by itself 4 times with a minus out front, so we need the opposite, so -16. If you see a negative in front of a radical as square root, it just means, yeah, the radical always means the positive square root, so radical 9 means 3, and we need the opposite of that, so -3. That's not the same as radical -9, so just remember there's no real number that when you square it you get -9, so for us square roots of negative numbers are just undefined. In this example we have a big power of a negative number. So if you have an odd power of a negative number, it's always negative. An even power is always positive. Yeah, we saw that already up here. So -3 to the power 3 was negative. 123 is an odd number. So this whole thing has to be negative. 1 to the power 123 is 1. So the answer is -1. If it was -1 to the power 124, that would be +1. Yeah, another thing to remember, anything to the power 0 is always 1. It doesn't matter what the base is, well, except for 0 to the power 0 is undefined, but any other base to the power 0 is 1. And powers of 0, well, this just means 0 times 0 times 0 times 0. That's definitely 0. Okay, so powers and roots. Chapter 3, we looked at fractions. The first thing we did was to try to draw them graphically. So 3 over 7, one way to draw it is to, you could start with a rectangle. We also looked at circles, but any kind of shape. The 7 on the bottom means divide the shape into 7 equal pieces, and then the top number says, shade in 3 of those 7 pieces. To get these fractions, it's really division. So this, another way to think of this is 3 divided by 7. All right, so 7 over 7, that would be 1. That would be the whole rectangle. But we don't have the whole rectangle. We just have 3/7. An example with a circle. So here I've divided the circle into 5 equal pieces and shaded 2 of them. Here's an improper fraction. The top is bigger than the bottom. So for improper fractions, like this, you need more than one rectangle. So 8/5, well, here are 5/5, and here are 3/5. So you can see this is more than one. It's a mixed number. It's 1 and 3/5. All right, so the bottom number, that's telling you how many equal pieces to break your shape up into, and the top number is telling you how many of those pieces you need. Here we need 8, so it's 5 plus another 3. All right, so for improper fractions where the top number is bigger than the bottom, you're going to need more than one circle or more than one rectangle. And yeah, it's not the same as 5/8. So the reciprocal of this is 5/8, but that's a different fraction. So if you take the rectangle, divide it into 8, and shade 5 of those, that's a different fraction. Simplifying fractions. So if the top number is the same as the bottom, that's the same as 4 divided by 4. That the answer is 1. If you have a 0 on top, well, 4 goes into 0 0 times, so the whole thing is 0. 4 goes into 8 2 times. How about this fraction, 2 over 4? Well, this simplifies. You can divide the top by 2 and the bottom by 2 to make it simpler. So 2 over 4 is equal to 1 over 2. So this is the idea of equivalent fractions. So the fractions can look a bit different, but they really represent the same number. If you drew the rectangles for these, you'd see it's the same amount of shading. How about 4 over 0? Can we simplify this? Well, yeah, any fraction over 0 is undefined. So this is not a good fraction. So anytime you see a 0 on the bottom, that's undefined. Anytime you see a 1 on the bottom, that means you really just have a whole number. 1 goes into 4 4 times. And also, if you want to write a whole number as a fraction, just put it over 1. Yeah, so our main idea for simplifying fractions is this formula. So if you have a common factor in the top and the bottom, so the same number multiplying everything on top and multiplying everything on the bottom, then you can cancel that common factor to get a simplified fraction. Here we did that with the common factor 2 here. For this example, 10 over 40, you can see there's a common factor 10. On the top, it's 1 times 10. On the bottom, it's 4 times 10. So it's like C is 10 here. So divide the top by 10, divide the bottom by 10. And we see the simplification. 10 over 40 is equal to 1 over 4. So this 1 over 4, that's the simplified version of 10/40ths. Same thing here. Maybe it's harder to see. We have 12 over 30. So can we simplify this fraction? Can we find a common factor between the top and the bottom? And ideally, we're looking for the greatest common factor. Here the answer is 6. So 12 is 2 times 6. 30 is 5 times 6. So they have a 6. Common factor is 6. And if you divide out that 6, yeah, you get 2/5. So in our jargon, so you want to simplify fractions into their lowest terms. So use numbers that are as small as possible. And yeah, you're always expected to do that. So if this was your answer, then you have to simplify that. So this is the best answer. And yeah, you might lose a point if your answer is not in lowest terms. Okay, and for this example, the greatest common factor of 12 and 30 is 6. So we're calling that the GCF. Okay, if you look at all the factors of 12 and all the factors of 30, so the greatest factor they have in common is 6. Okay, so when you're reducing fractions to lowest terms, if you want to do it in one step, then use the greatest common factor of the top and the bottom. Okay, another way to find greatest common factors is to look at the prime factorizations. Okay, so we could look at the prime factorization of 12. So we use this factor tree idea. So 12 breaks up as 4 times 3. 3 is a prime number, so you could circle it. 4 is not a prime number. 4 is composite. It breaks up into smaller pieces, 2 times 2. Okay, so this is kind of like an upside down tree. At the bottom we have these pieces. So at the end of each branch, 2, 2, and 3. So those are the prime factors. So the prime factorization of 12 is 2 times 2 times 3. Okay, how about the prime factorization of 30? Well, 30, you can break that up as 3 times 10. 3 is prime. 10 is not prime. 10 breaks further into 2 times 5. Okay, so the factor tree for 30 can look like this. Or you could have done, say, 6 times 5, and then 6 is 2 times 3. But you'll get the same answer, so the prime factorization of 30 is 2 times 3 times 5. And this gives us another way to see the greatest common factor. So you can see they have a single 2 in common and a single 3 in common. So here's what they have in common, 2 times 3. So the GCF is definitely 6. Okay, so that's an important idea, the greatest common factor, GCF, and it's useful for simplifying fractions into lowest terms. Another idea we need is least common multiple. Okay, so it's not the same thing. So the GCF of 12 and 30 was 6. The least common multiple of 12 and 30 is 60. Okay, so the LCM is always bigger than the two numbers. The GCF is always smaller. So if you look at the multiples of 12, 12, 24, 36, 48, 60, 72. The multiples of 30, 30, 60, 90. And now we're looking for the least or the smallest multiple they have in common. So the smallest number that's the same in both lists is 60. If you continue these lists, you'll see 120 is a common multiple, but we're looking for the smallest. And the least common denominator for two fractions means the least common multiple of all the denominators. All right, so that's LCD. So the LCD is really the LCM of the denominators. So if you're looking at, say, 1/12 and 3 and 7/30, so the denominators are 12 and 30. The least common multiple of 12 and 30 is 60. So 60 is the LCD for these two fractions. And why do we need LCDs? Well, if you're adding, subtracting, or comparing fractions, two or more fractions, you need the least common denominator. So if you want to add these two guys, there's no way to do it directly. So 8 over 42. I'm sure I'll see some answers like that, but that's not the correct way to add these. You need a common denominator. We can use 60. So what do you need to multiply 30 by to get 60? You need 2. So multiply the top and bottom by 2. Okay, so 7 over 30 is equivalent to 14 over 60. What do you have to multiply 12 by to get 60? 5. So hit 1/12 With 5's top and bottom, you get 5 over 60. Now, if the denominators are the same, then you can just add the tops together. So 14 sixtieths plus 5 sixtieths is 19 sixtieths. So I hope you've had some practice adding fractions with different denominators. The first thing to do is to work out the LCD. That's just the least common multiple of the two denominators. And exactly the same for subtraction. So that's just 14 over 60 minus 5 over 60, so 9 over 60. Okay, so if you're adding and subtracting fractions with the same denominators, then you just keep that same denominator and add or subtract the tops. Yeah, there's one more step here. So this 9 over 60, it's not in lowest terms. You can see there's a common factor 3. So cancel 3's to get 3 over 20. Again, for any answers, you make sure they're in lowest terms. And yeah, also comparing fractions. So if I asked you which is bigger, 7 over 30 or 1 over 12, then write them over the same denominator. So yeah, you can definitely see that 14 over 60 is bigger than 5 over 60. So 7 over 30 is greater than 1 over 12. Okay, so you need an LCD when you're adding, subtracting, or comparing the size of fractions. If you're multiplying fractions, then you don't need the LCD. It's easier. And just remember to go straight across when you're multiplying. So 3 over 4 times 5 over 7 is 3 times 5 on top and 4 times 7 on the bottom. So that's 15 over 28. Okay, so cross multiplying, that's not how you multiply two fractions. How about this one? 15 times 4/9. So 15 is a whole number, but like we saw before, you can make it a fraction, just put it over 1. So 15 over 1 times 4 over 9 goes straight across. That's 60 over 9. Common factor 3 you can cancel, so that's 20 over 3. Yeah, improper fractions, you don't have to convert them to mixed numbers unless you want to. 20 over 3. Here we're multiplying 3 fractions. It's the same idea, so you could do it the same way. So just go straight across. 10 times 14 times 3 on top. 140 times 3, 420. On the bottom, 7 times 9 is 63 times 20, whatever that is, another big number. 1,260. Okay, so that gives the answer, but then you expected to simplify it. There is a better way. So pre-canceling, yeah, I know it's not very popular, but it is the best way to avoid big numbers here. For example, yeah, you can see this. There's a 7 on the bottom. Are there any 7s on the top that we can cancel it with? Yeah, so 14 is 2 times 7. Also, this 3, there's a 3 in the 9 that it cancels with. And 20 is 2 times 10. So yeah, in fact, there's a huge amount of cancellation here. Okay, so all these numbers are being multiplied on the top. All these numbers are being multiplied on the bottom. So any numbers that match, top and bottom, can be canceled. And so this is the pre-canceling idea. So we're canceling before doing any multiplication. All right, we're left with a 2 on the top, 3 on the bottom, and a times 2. In fact, yeah, these 2's also cancel. So 2 is really 2 times 1, so there's still a 1 left. So what's left? Yeah, just 1 over 3. So in fact, yeah, for this question, we really didn't need to do any multiplication. It's just if you factor these numbers and look for common factors to cancel, then it's really a much easier way to do this question. So 1/3. All right, so yeah, if you wrote, what was it, 420 over 1,260, that's correct. But to simplify it, yeah, I guess the greatest common factor between those two numbers is 420. So it reduces to 1/3. And the last operation, division. So dividing by a fraction is the same as multiplying by the reciprocal. So dividing by 9/5 is the same as multiplying by 5/9. Keep change flip. And once you have it as a multiplication, then just go straight across. 3 times 5 is 15. 4 times 9 is 36. So that's 15 over 36. Cancel the 3's, common factor 3. So that's 5/12. Or you could have done this with pre-cancellation. Cancel that 3 with the 3 out of the 9. And then do the multiplication, 5/12. All right, so adding, subtracting, multiplying, and dividing fractions, that's how that works. And just to review one last topic, mixed numbers. Okay, so any improper fraction, you can convert it to a mixed number. And the way that works is you do a division. All right, so this fraction means 13 divided by 5, or 5 into 13. So when you do the division, here 13 goes into, 5 goes into 13 2 times. 2 times 5 is 10. Subtract the 10, there's 3 left over. So the quotient gives you the whole number part of the mixed number. The remainder gives you the top of the fraction piece, and the same numbers on the bottom. So 2 3/5. Yeah, a nice way to remember it is it's kind of this circular pattern. So 2 and 3/5. All right, so it works like that. Yeah, again, the quotient, that's the whole number piece. Going backwards, so it's often useful to convert mixed numbers back to improper fractions. So here we have 7 and 2/9. So every 1 you can write as 9/9. So it's 7 of those 9/9, and so that's 7 times 9. That's 63, plus another 2/9. So plus. All right, so so these numbers get multiplied and then add on the 2. So 7 times 9 is 63, plus 2 is 65 over the same denominator. Okay, so just this kind of simple formula to get the top number, the whole number times the bottom plus the top. So as an improper fraction, it's 65 over 9. And yeah, so if you're multiplying two mixed numbers, for example, or dividing or adding or subtracting, you can, well, certainly for multiplying and dividing, you have to convert them into improper fractions first. For adding and subtracting mixed numbers, yeah, we saw it's sometimes easier to add and subtract the whole number part and the fraction part separately, but if you don't mind big numbers, then you can always convert mixed numbers to improper fractions first, and then just add, subtract, multiply, and divide the fractions like we were doing here. All right, so that's just a review of the first 3 chapters. So the midterm questions. So I'll just be taking homework questions and maybe changing the numbers. So do look back over all the homework questions.